to tell you about what is MESFET. So basically, the MESFET is metal semiconductor FET transistor or Schottky gate FET. So this MESFET, as we can know, is consists of a conducting channel positioned between a source and a drain contact region. But the carry flow from source to drain is controlled by the Schottky metal gate. And then the control of the channel is obtained by varying the depleting layer with underneath the metal contact, which modulates the thickness of the conducting channel and thereby the current. Okay, now I want to explain about the structure of MESFET. Okay, first, the conducting layer or channel layer is the region that's located between drain and source contact region. It is the site where electron move from source to drain. Next, the gate is located in the middle of the MESFET. It was the base that imparts resistance and control the movement of the electron. Next, the drain contact region was the emitter and the source contact region was the collector. Okay, for the semi-insulating, mostly we use for the MESFET we use gallium arsenide. Why we use gallium arsenide? Because gallium arsenide is higher electron mobility compared to the other metals such as indium phosphide and silicon carbide. Next, N-type channel is located under the channel layer. Why microwave transistor always N-type? Because electron mobility is almost 20 times greater than the hole mobility. Therefore, highly doped layer or N+ layer is located above the N-type channel. So where? It's located below of ohmic contact to create low resistance of ohmic contact. So what is ohmic contact? Ohmic contact is between the drain and source. The function to create a highly doped layer and create Schottky contact. Okay.
Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to represent to you about the basic operation of MESFET. MESFET are made in two types. There is enhancement, normally off, and depletion is normally on. In enhancement devices, built-in voltage causes the channel to be completely closed, a zero gate source bias. Voltage drain is equal to 0 and requires a positive voltage gate. For depletion devices, voltage gate must be 0 and voltage drain also must be 0. Depletion region extend only partly across the channel, possible to modulate the width of the channel. And these devices can be decreased by applying a negative voltage to gate, and second one is applying a positive voltage to the drain. That's all from me.
Today I will continue the presentation about the MESFET. The importance of MESFET is the threshold voltage. VA is voltage applied from metal to semiconductor bulk and its function of both VG and VD, which is voltage gate and voltage drain. VBI is the built-in voltage across the depletion layer and its positive quantity for both types of devices. Voltage that must exist across the depletion region to completely pinch the channel is defined as the pitch-off voltage. The formula is Vp Q ND over 2 epsilon naught and epsilon R times by A square. Next, if voltage drain equal to 0, the VBI causes the depletion region to extend across the part of the channel with as in depletion time. Negative voltage must be applied to the gate to close the channel between source and the drain. Next, the negative voltage we label it as threshold voltage. This is two important equation we need to understand. Vp equal to Vbi minus Vt, and Vt equal to Vbi minus Vp. When the Vbi is more than sufficient to close the channel, the positive voltage must be applied to reduce the width of the depletion layer. At this situation, Vbi will larger than Vp, so the threshold voltage is positive. It will enhance type device. To clear understanding, then we assume that Vd, V drain equal to 0, Vp equal to Vbi minus Vt, and Vt Vbi minus Vp.
Hi, I'm back. So today I'm going to explain more about the relationship between the voltage. So when the cause of the pinch off at the drain end of the channel, the depletion layer will increase. So by using the formula Vd plus Vbi minus Vg is equal to Vp, where Vd is the drain voltage, Vbi is the built-in voltage across the depletion layer, Vg is the gate voltage, and the Vp is the pinch off voltage. But when for Vg, when the voltage gate is equal to 0, the channel will pinch off at the drain end when. So automatically the drain voltage is equal to the V SAT and equal to Vp minus the built-in voltage. V SAT is the drain voltage at the point of saturation of the drain current. But when the Vd equal to 0, the channel is pinched off throughout its length when the formula is voltage gate will equals to the built-in voltage minus to the pinch off voltage. So the channel is completely closed when Vg is equal to Vt. So the drain current is 0. But when Vb is equal or greater than the pinch off voltage, the drain current begins to flow when Vg is larger than Vt and Vg is larger than 0. So the formula is Vt is equal to built-in voltage minus with the pinch off voltage. So this relation for the threshold voltage is the same for the depletion and enhancement type device. So lastly, here is our formula. You can read after this. The ID here is the drain current, and this equation is only valid if the channel is not pinched off.
Hi, I'm back. Today I will represent to you about the depletion mode versus enhanced mode. The difference between the depletion mode versus enhanced mode is the device is naturally on for the depletion mode and normally off for the enhancement mode. The depletion layer for the depletion mode is smaller, and for the enhancement mode is bigger or pinch off. The current flow in channel, of course the depletion mode have the current flow in channel, but in enhancement mode does not have current flow in channel. For the threshold voltage, the depletion mode is negative and the enhancement mode is positive. For the voltage supply to gate, the depletion mode is reverse bias and the enhancement mode is forward bias. For current influence, the depletion mode, the current influence by voltage drain is for depletion mode, and the current influence by voltage gate is for enhancement mode. That's all from me.
After all we have learned about the MESFET, there is two applications of the MESFET. First, high frequency RF amplifier application devices, cellular phone, satellite receivers, and military radar. Also used in microwave devices. Okay, that's it.
That's all
From
Us.